Hi there. Today we are going to see the practical session where we are going to learn about the telescopes and what are the types of telescope and what we will do with the telescopes in nowadays. The question comes when we are dealing with the telescope. Where to look and what to look for, as the telescope had a two different function. First, to make a small things look bigger or to make a fan things brighter. You control which of those rules it's doing by the eyepiece you have chosen. Now, in eyepiece power, you are trading off the magnification against the brightness and the field of view. The shorter wavelength of the eyepiece will give you higher magnification, and the longer wavelength of the eyepiece will generally give you greater field of view. Extended objects like an open cluster need low power to fit in the field of view. Dim objects like galaxies need low power to concentrate their light. Small bright objects like planets, double star may need a high power eyepiece. Planetary nebulas are smaller but dim. Since the lower power eyepiece shows you more of the sky, a good technique is to find the object with the low power and then observe it with the medium power, and if still you want it, then you can try high power if it is brightened enough or sky is dark enough, depends upon the light quality available in the sky. Most of the objects like Orion nebulas are interesting under both low power and high power. Low power make the faint object appear brighter. Unfortunately, it can also make the moody subbrance sky brightens as well. Sometime once you have found the faint object in a low power, you can increase the contrast against the sky by switching the high power eyepiece. Now, first, what we need is the map for each object, and the best map is our naked eye. These are charts generally shows the stars down to the third magnification. On the best night, the human eye can see down to about the 16th magnitude without telescope and with the glow of the city's light. Next, we find the viewfinders. The little but a telescope, small but a telescope. Viewfinder scope usually comes in a small sizes and orientations. We have assumed that if you have a viewfinder, your image will be turned upside down. That means it will be a mirror image. But it does not give the mirror image of the sky. It will give a mirror image of that object. Now the third is what we have is the telescope view. What the object should look like through your eyepiece usually give us two views. One as seen in a small telescope through the star diagonals, and other is through the Newtonian telescope. These are the what we find in a telescopes. First, we all use looking at the road map when we are driving somewhere. Geographical atlas or map is the things on the ground under our feet. Therefore, traditionally, north is always up and east is to the right. However, when we look at the sky, our orientation is just backward from looking at the ground. Instead of being outside of the globe of the earth looking down, we are inside the globe of the earth and looking up. It's like looking at the barber shops painted from the inside. Next, many viewfinders are simply two lens telescopes. This means that amongst other things, they turn everything upside down. Binoculars and opera glasses have extra lenses in them to correct this upside down error. The star field as it appears in the naked eye is shown in your diagram. And the Newtonian or Dobsonian telescope will show like this. It is, you can see it's a mirror image in the north and south reversed and east and west reversed. Simple telescope without a star diagonals. And this is what the reflector telescope shows. The image is mirror upside down. North is there, south is there, but it is reverse. East is opposite to that toward the right and west is toward the left. The arrow shows the direction that the star will drift, will move, moving from east to west across the field of view. There are some software online available for this purpose. Types of telescope. Now, there are basically three types of telescope. And astronomical telescopes have two very different jobs. It must make the dim object look brighter. It must make the small object look bigger. The telescope accomplish these two jobs in two stages. Every telescope starts with the big lens or mirror and is called object or object lens. These lens or mirrors is designed to catch as much light as possible. The same way as a bucket is set out in the rain to catch the rainwater. Obviously, the wider this lens or mirror, the more light can be catch. And more light is catch, the brighter it make the dim objects appear. Thus, the first important measurement you should know about your telescope is the diameter of the object. That is what we call aperture. Now, if your telescope use a lens to collect the light, it is called a refractor type telescope. It use a mirror also, and the mirror is used to reflect these coming lights into the eyepiece. In the reflector, the light is refracted or bended by a large lens, which is we call as an object lens. The light is reflected from the primary mirror, sometimes called object mirror, and to the small setting in front of the eyepiece. A reflector is another type of called catadioptric refractor. In this, what happens? The object reflects whole light on the curved mirror given at the back of the refractor, and from there it is reflected to a small mirror, and then it is collected in a curved primary mirror over here, small one, which is reflected into the eyepiece. The reflected where the light is sent back through the hole in the main mirror is called Cassegrain reflected type. Cassegrain reflectors have, in addition to a lens in front of the primary mirror, allows the telescope tube to be shortened or smaller. That means these are the smaller telescope available in the market, but these are costlier. Now, about the reflectors, there are a telescope which are known as a Newtonian or Dobson telescope. The reflecting telescope in which the secondary mirror bounce the light side back through the hole near the top of the telescope's tube. Over here, top of the telescope tube is called as a Newtonian reflector. The most popular amateur version of Newtonian reflectors is known as Dobson. A Newtonian with the simple but elegant azimuthal mount invented by the John Dobson. The primary mirror bent the light to the concentrate to it down to a small bright image at a point and is called the focal point. Type of mounts. There are two types of basic types of mounts: azimuthal and equilateral bottom. The equilateral bottom is effectively an azimuthal mount which has been tilted so that one axis should turn with the earth. This was tilted. Small telescope often come within one tripod similar to the camera tripod, which let you tilt the little scope up and down or turn it left and right. The up and down direction is called latitude. Shifting left and right moves you through the azimuth. Such a mount is called known as an azimuthal mount. For small telescope, this is perfectly reasonable sort of mount. And this type of mount is light-weighted, require no specific alignment, and it is easy to use, since you all have to do is to point the telescope where you want it to look. Popular inexpensive azimuthal mount is the Dobson mount. Instead of tripod supporting the center of telescope tube, a Dobson is mounted near the bottom. To correct these motions, a fancier type of mount is found, and it is known as an equilateral mount. This is, we can be thought of the azimuthal mount with only a tripod, but the axis that used to point straight up and down, point towards the celestial north pole, or tilt it at the 90-degree, that sort of correction will be done with the equilateral axis. Now with this sort of mount, you can just turn the telescope about this tripod axis in the direction opposite to the earth spin. So keep the object you are observing center in the telescope. You can even attach a motor over here in an equilateral mount and turn your telescope according to motor direction. The motor is called clock driver. It is turn the telescope about the tripod axis at the half the speed of the hour's hand in the clock. Does it make one rotation every day? Next is the eyepiece. There are many types of eyepiece there. Now, when we talk about the eyepiece, we have to find which eyepiece we needed for which type of the objects. As we have discussed about something in the eyepiece section also. But you have to take good care of your eyepiece lenses. They come in a 25 milliamp, 10 milliamp, 4 milliamp. One fingerprint, a few dust grain, your eyepiece performance will be dimmed and your telescope cannot do anything. And your moon will appear rather than a glare, glaring type where it has been very clean when you are using first. So you have to make sure your eyepiece are clean. Anything which you use to apply cleaning solution, rinse off the rubbering and grime across the coating. So whenever you are using a good chemical on the eyepiece, you should take care and see whether it is for the telescope eyepiece or not. Apertures. As we are discussing the apertures, whatever the telescope you are using, you should know what is the aperture. The aperture is actually important measurement that you should do before buying a telescope, which is the actual diameter of your object, what we are using in a telescope. Now here you can see C19, that means the aperture is 90 millimeter. The easiest way to determine the focal length is simply to find the number written on the side of your telescope or the eyepiece. As you can see, this is 25 millimeter. The eyepiece to the having a focal length of 25 millimeter combined with your telescope with the 1000 mm. It is important that you should know the aperture of your telescope. 90 millimeter, as you can see, the focal length f or f by 11, that means thousands by 90. Using the 25 millimeter eyepiece in this telescope would give you a magnification of 40x, which is good enough because you have to divide 1000 by 25. That is the magnification power. Now for the live demo, click on the link and you can